We will start. Students, in the last class we have done up to question number 4. So we are discussing today question number 5. Okay, from question number 5, and for the students they joined in today, they are joining today, or the students they joined late. For that I will discuss from question number 1 after we complete question number 20. Okay, so we will go like a cycle from question number 1 to question number 20. Then after completing question number 20, we will go back to question number 1 and we will repeat, so that those questions will be covered for the students they are joining late in the class. Then today we will discuss question number 5, question 6, 7 and 8. Okay, so in the worksheet, I hope all of you have printed this worksheet. So we will discuss question number 5, 6, 7, 8 today. So grade 10, grade So we are starting with the EOT question number 5. Okay, question 5 from EOT. Okay, so yeah, EOT question number 5, I will write EOT question 5. Okay, EOT question number 5. So question number 5 is relate the wavelength, frequency and the speed of a sound wave by the equation lambda is equal to V over F, right? So that is the relationship between the wavelength lambda, speed and frequency. Lambda, that is equal to speed over frequency. This is the relationship between wavelength, speed and frequency of a sound wave. So in this equation, lambda, that is equal to wavelength, lambda represent wavelength of the wave, V represent speed of the wave, and F represent the frequency of the wave. So just I will add the unit here. What is the unit of wavelength? Unit of wavelength is meter, unit is meter. Unit of speed is meter per second, and unit of frequency is hertz. And there are some questions given here. So in that, question number 14 to 23 from page number 15 of your textbook, question number 14 to 23. Okay, from page number 15 of the textbook. So I will erase this so that we will get a space here to solve those questions. So here you can see there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 questions given. So we will not solve all the questions. Okay, all the questions are almost similar. So we will solve some questions in between. And I have already sent the answers of all the questions that you can refer. So question number 14 we will discuss. Question 14. A sound wave produced by a clock is heard 515 meter away 1.5 second later, right? Based on these measurements, what is the speed of sound in air? So we have two equations to calculate the speed of sound. We have two equations. Okay, we have two equations to calculate the speed of sound. So speed of sound, you can write this in your notebook, or if you have space in the worksheet, you can write that. Speed of sound we represent by the letter V. To calculate speed of sound, we have two equations. One equation is speed is equal to distance divided by time. Speed is equal to distance divided by time. Distance traveled by the wave divided by the time taken. And another equation to calculate the speed is equal to frequency of the wave multiplied the wavelength. So we have two equations to calculate the speed of sound. So in this question, a sound wave produced by a clock is heard 515 meter away. Distance is given, 515 meter is the distance, and the sound is heard 1.5 second later, which means time is given 1.5 second later. A sound wave produced by a clock chime is heard 500 meter away. So the clock is here and you are 515 meter away, and you hear the sound after 1.5 second. Based on this measurement, what is the speed of sound in the air? Speed of sound, question mark, we have to calculate speed of sound. This is very easy question, very direct question. That is, speed is equal to distance divided by time. If we use this equation, speed is equal to distance is 515 and time is 1.5. 515 divided by 1.5 that is equal to 343 meter per second. Then how much? 343, right? Yeah, okay, correct, right? Okay, yes, done. Okay, then next is the question B. Okay, now we will discuss the question B in question number 14. Question B says the sound wave has a frequency of 436 hertz. So frequency is given in that question. 436 hertz is the frequency of the sound wave. What is the period of the wave? We need to calculate the time period. In that question, we need to calculate the time period. Period of a wave we represent by the letter T, capital letter T, and frequency we represent by the letter F. So in this question, frequency of the wave is 436 hertz, and the time period we need to calculate. We have the equation to calculate time period. Time period is equal to 1 over frequency. You must remember these equations. Okay, equations will be given in the exam, but if it is not given, you should not be worried. So you should by heart these equations. Time period is equal to 1 over frequency. So time period that is equal to 1 divided by 436. 1 divided by 436, that is equal to 2.29 times 10 to the power negative 3. Unit of time period is second. So if your calculator is not in standard form, then you will be getting an answer 0.00229. So 0.00229, right? 229 second. So if you get the answer like this, or if your answer is in standard form, you will get the answer like this. Okay, both are correct, means both are same, there is no difference. Then yes,
can you please give us time to write because you stood in front of the board?
I will give you time. Okay, you can write now.
Yes.
Okay, question number C. Question C of this question 14. What is the wavelength? So here you have to calculate the wavelength. To calculate the wavelength, you have this equation. Okay, we will use this equation to calculate wavelength. So wavelength lambda, that is equal to, you can see, speed divided by frequency. Okay, wavelength lambda is equal to speed over frequency. They will give maybe one equation like this in the exam, but you should know what is the equation for speed, what is the equation for frequency, like that. For example, here I have given one equation, v is equal to f lambda. From that equation we are writing equation for wavelength. So wavelength lambda, that is equal to, wavelength lambda is equal to speed divided by frequency. what is the speed of the wave that we calculated, right? Speed we calculated, that is 343 divided by frequency. Okay, 343.3, right? No problem. So there will be small difference, it's okay. 436, right? You said this one, when I calculate, we will get 343.3, right? Okay. So divided by 436, right? 436. So what is the answer? When we divide, the answer will be 0.787. 0.787. The unit is meter. So 0.787 meter. Like 3 questions I will discuss, okay? 3 questions from this, and the remaining questions I will solve in the worksheet I have done already and I send it to you. You can refer if you have any doubt that you can ask later. Can I erase this? Question number 15, how are the wavelength Question number 15, how are the wavelength, frequency and the speed of a wave related? That we have already said, right? How are they related? The wavelength, frequency and the speed. The wavelength, frequency and the speed are related like this. Wavelength is equal to speed over frequency. Now I am discussing, yes, question number 15, okay? Question number 15 from this worksheet, question 15 from this worksheet. How do they depend on the medium through which the wave is passing? And how do they depend on the medium through which the wave is passing, right? So first we will talk about frequency. Frequency do not depend on the medium, okay? Frequency will not depend on the medium. So I will write frequency do not depend on the medium. Frequency do not depend on the medium. For example, the frequency of the sound, that depends on the source which is producing that, okay? Frequency of a wave. For example, if I make like this, okay? Like this if I make, so how many times I am making in 1 second? For example, 1 2 3 4, in 1 second 5 times I am doing this. So the frequency is 5, right? Frequency is 5. Frequency of a wave depends on the source of the wave, what is producing that wave. So frequency depend only on the source of the wave, okay? For example, you are talking, so the frequency of the sound you are producing, that depend only on you, means like how many times your vocal cord is vibrating. It does not depend the medium, like means it does not depend on the condition of the air. So frequency of a wave do not depend on the medium. It depends only on the source which is producing that wave, okay? So frequency of a wave, frequency depends only on the source, which is only on the source of the wave, okay? Only on the source of the wave. Number 2, speed. V. Speed depend on the medium, okay? Speed of a wave depend on the medium. Speed of a wave depend on the medium. For example, if I take the sound wave, the speed of sound, okay? Speed of sound in air, that is around 343 meter per second. Speed of sound in water is around 1000 500 meter per second. Okay, speed of sound in liquids. This is not exact value. I am writing means a value that is a near values. Okay, and the speed of sound in iron, for example in metal, that is around 5000 meter per second, which means speed of sound depend on the medium. Speed of sound will be different in different medium. So speed of a wave depend on the medium. Speed changes when you change the medium. Okay, and one student,
On the medium or don't depend on the medium?
which one?
What means depend on the medium?
Okay, what means depend on the medium, and what does not mean not to depend on the medium, right? Okay, for example, okay, first I will tell like this. Okay, what example will I give you? Easy example. Okay, my body weight is 65 kilogram. Okay, my body weight is 65 kilogram is my body weight, like body weight of a person. Okay, I am not telling my body weight of a person, that is 65 kilogram. Will his body weight change if he eat more food every day? Like the quantity of food is he eating, like when he eat more food every day, he is eating more and more. So will it depend on his body weight? Will the body weight change? Yes, right, which means the weight of a person, the body weight of a person depend on the food he eat, right? If he eat more food, his body weight will increase. If he eat more junk food, also his body weight will increase, right? And for this person's height is, for example, 170. Okay, that no need, because adult the length height will not change, right, for an adult. Okay, but for the children it will change. When he eat, it will grow, right? So what I will do, like this, age, we can say age. For example, this person's age is 20 years. Okay, will his age depend on the food he eat? If he eat more food, will his age change?
No.
Age will not change, right? So age is not depending on the food he eat, right? Do you understand? So depend means when this change, his body mass is changing, which means the body mass depend on the food. Okay, on the food he eat, but his age will not change if he change how much food he is eating. Correct? You understand?
Yes.
Okay, so you understand the meaning of depend and not depend, right?
Yes.
Okay, enough. Good question. So yes, there is one more thing, right? Speed, wavelength, right? Wavelength. Will wavelength depend on the medium? That is a question. Wavelength, you should remember this. Okay, wavelength means the distance traveled by one wave. Okay, what is the meaning of wavelength? Distance traveled by one wave. For example, suppose you are walking. So you are traveling, for example, you are walking for 1 second. Okay, 1 second you are walking, 1 second you walk like this. So that distance traveled we can consider wavelength. Okay, for example, you are a wave, and that wave is walking in 1 second. Okay, for example, in 1 second, suppose time period is 1 second. that distance is called wavelength. If that wave walk very fast, if the wave is walking very fast, so it will cover more distance, right? It will cover more distance. So when speed changes, wavelength will also change. That is why wavelength of a wave will depend on the medium. Okay, wavelength will depend on the medium. The reason is the speed will change. When medium changes, the speed will change. When speed change, the wavelength will change. So I will write these things in short. Okay, so here it is more written. I will reduce this and I will write it in a very short, like the way that you can remember. You must remember, okay, you must remember everything what we discuss in the class. So I will write the way, I will give you like a capsule. I will try to give you like a capsule that you can remember every time. So first frequency do not depend on the medium, right? Frequency do not depend on the medium. So do not, I will write no. Okay, no depend on medium, so I will just write no medium. Okay, no frequency, no, yes. Then speed, tell speed, speed will depend on the medium, right? Yes. And wavelength, yes. So you can remember like this. Okay, you can remember this way. Frequency do not depend on the medium, so I just wrote no medium. Speed, yes, depend on the medium. Wavelength, yes, depend on the medium. Why wavelength depend? Because speed depends. Wavelength is distance traveled by one wave. If it travel with greater speed, it will cover more distance, right? So wavelength will change. Question number 17. How does increasing the wavelength by 50% affect the frequency on a rope? Question number 17. Okay, question number 17 in that worksheet. How does increasing the wavelength by 50% affect the frequency of wave on rope? So we have equation for frequency. Frequency F is equal to V divided by lambda. So in this question, V is not changing. V no change. No change. In V no change. We are not changing the speed, but we are changing the wavelength. We are increasing the wavelength to 50%. So if we increase the wavelength to 50%, means before initial wavelength was lambda. Lambda plus 50% is 0.5, right? 0.5 lambda, which means now the new lambda, the new wavelength is equal to 1.5 times the initial wavelength, the old wavelength. Okay, when you increase something by 50%, so it will be 1.5 times, right? 1.5 times. So what will be the change in the frequency? What will be the new frequency? The new frequency is equal to V divided by new lambda. V divided by new lambda is 1.5 lambda, right? 1.5 lambda. So from here you can see V by lambda is the initial frequency. So the new frequency will be the initial frequency divided by 1.5. So you will get, when you divide, you will get 0.67, which means 0.67 times the initial frequency. Okay, this is the answer. Yes.
Why we make robot faster? If we multiply by 3%, it will give 0.85. Not 1.5.
Okay, so here you can see this is the wave like this. Now here we have two waves, right? Here we have two waves. If I increase the wavelength, so we have two waves, right? For example, this is completed in 1 second. So what is the frequency of this wave? Frequency means number of waves, right? Number of waves completed in 1 second. For example, this is for 1 second. So here frequency is 2. And wavelength is the distance from here to here, right? This is the wavelength. So if I increase the wavelength, means if I make the wave bigger like this I increased it too much. So if I increase the wave like this, so now the wavelength is increased. Now the wavelength is from here to here. Wavelength is increased. So when you increase the wavelength, frequency will decrease, right? Frequency will decrease. That is the first thing I want to tell you in this question. When you increase the wavelength of a wave, the frequency will decrease. Okay, frequency will decrease. When you increase the wavelength of a wave, frequency will decrease. That I will draw two waves. From that you will understand that concept better. When you increase the wavelength, frequency will decrease. So how can you understand from two diagram? For example, this is one wave. It's like this. One wave. Which one? Okay, this is another wave. Can you tell which wave has greater frequency? Which one has greater frequency? First one or the second one? First one has greater frequency, right? So number 1, greater frequency. Number 2, less frequency, right? Which one has greater wavelength? You can see its wavelength is from distance from here to here, right? Or in the book it will be shown from here to here, right? This is the wavelength, correct? This length is wavelength, right? So here the wavelength is from here to here, right? Okay, so which one has greater wavelength? Second one, right? Second one, greater wavelength. Okay, so that you can understand from the diagram what is the meaning of greater frequency and greater wavelength. And if you increase the wavelength, you can image, means you will get the image. If you increase the wavelength, then frequency will decrease. Do you understand that concept? Can I erase this? Okay, I will go back to that. For example, you have 2 orange, okay, 2 orange. Your mother is giving 2 oranges or 2 apples. Okay, so one she gave to you, one she gave to your sister. Okay, you have now 1 apple, right? You are here, you go to 1 apple. Your sister here, 1 apple, 1 apple. Okay, your sister here, your sister got 1 apple. So what she did is she cut this into 2 half. So she got 1 half like this, 1 half like this, right? So this is her apple. Okay, you are eating one full. Then she gave one half to you. One half means 50%, right? Correct? 50% of one apple, right? So she gave one half of her apple to you. So now you go to this. Correct? Okay, so how much you got? You got one apple. You got one apple plus half of the apple. Half means 0.5, right? Half of one apple. Okay, so how many apple you got? You got 1.5 apples. Do you understand this? Okay, just like that, increasing 50% means you are getting half of that. Okay, you are getting additional half. Increasing 50% means you are getting additional half. Do you understand? So that is why before the lambda was wavelength was lambda. Now you are increasing by 50%. So new lambda will be equal to lambda plus half of the lambda, right? Half of the wavelength. New wavelength is equal to the wavelength plus half of that. So one apple plus half of the apple, that is 1.5 apple. Just like that, 1 lambda plus half of the lambda, 1.5 lambda. Okay. You asked that question. Who understand this? From here. Yeah, this equation, right? So this is okay, right? This part also okay, right? We just substituted the new lambda. So you can see from here, what is frequency? Frequency is V by F, right? Correct? So here, yeah, sorry, V by F, not V by F, V by lambda. V by lambda is the frequency, okay? V by lambda is F, right? V by lambda is F. So this is F. I wrote F. What is remaining? 1.5 is remaining, right? So 1.5 we wrote here. Okay. So F divided by 1 by 1.5 will be 0.67. Okay. 1 divided by 1.5 is 0.67. That's why. So I have given all the answers in the worksheet. You can refer to that. If you do not understand any question, you can ask in the group, WhatsApp group, or you can ask in my personal message. I think better to ask in the WhatsApp group, so other students may have the same doubt, so they can get that answer with your question. Okay, question number 6, EOT question number 6. Okay, EOT question number 6. EOT question number 6. Describe the sound level and define decibel as a unit measuring the sound level. So sound level is related to loudness. Okay, sound level is related to loudness of sound. Loudness is actually related to the amplitude of the sound. Do you understand? Loudness is related to amplitude. Okay, so what is the meaning of amplitude? Amplitude means if this is a wave, if this one is a wave like this, so the maximum displacement from the equilibrium position, that is this one, right? This is called amplitude. This is the equilibrium position. This line represents the equilibrium position, and this represents the maximum displacement of the wave from the equilibrium position. This one, this is also maximum displacement. This is also maximum displacement. These are called amplitude. Amplitude. So what is amplitude? Amplitude is maximum displacement, amplitude is maximum displacement from equilibrium position. So this horizontal line, this blue color line, you can see that represent the equilibrium position. So I will draw another wave with a greater amplitude. So you have to just see how that wave look like. If you draw another wave with a greater amplitude, so it will be like this, right? Correct? So now it has greater, this is the amplitude, so greater amplitude. So what happens when amplitude increases, the loudness increases. For example, the sound produced by a bird will have smaller amplitude compared to the sound produced by a lion, like that. I hope you will understand. So when you increase the amplitude, which means the loudness will increase. Loudness increase means the sound level will increase. So this is enough for that concept. And now there is a question given. Question number 9. How many times greater is sound pressure level of a typical rock? So what is the unit of sound pressure level? Unit of sound level is decibel. Okay, unit of sound level is decibel. Decibel we represent by dB, that is the unit of loudness or unit of sound pressure level. So here we have two sound. One is a rock concert. The sound pressure level of rock concert, that I will write L1. L1 is equal to 110 decibel, and L2, that is equal to the sound level is 50 decibel, that is the loudness of the normal talking. So what is the difference in loudness or difference in sound pressure level? So difference, sound pressure level difference, right? Sound pressure level difference, that is equal to L2 or L1, right? L1 is bigger, so L1 minus L2, L1 is 110 minus L2, that is 6, means one of the sound. Okay, so the answer will be equal to 50 decibel, that is the difference in sound pressure level. Correct, very good. This is 50 and this is 60, right? 60 decibel, that is the difference in sound pressure level. Okay, the next step, if the question is what is the difference in intensity, what is the difference in intensity, what is the difference in intensity of sound? Okay, so difference in intensity, so I will say delta intensity. So how to find a difference in intensity? That is equal to 10 to the power L2 or L1. Okay, 10 to the power L1 minus L2 divided by 10. This is how we find the difference in intensity. Okay, you can remember this. So 10 to the power, what is L1 minus L2? L1 minus L2 is 60, right? 60 divided by 10, 60 divided by 10, that is equal to 6, right? So difference in intensity will be 10 to the power 6. If you do not understand that section, you can ask. I know this section everybody will understand. Do you understand, all of you, this one? Okay, so this is the equation. Okay, this is the equation for the difference in intensity, equation for difference in intensity. I wrote delta to show difference spelling difference. Okay, difference in intensity. Okay, difference in intensity, that is equal to 10 to the power L1 minus L2 divided by 10. Okay, equal to 10 to the power, what is L1? L1 is 110, right? The loudness of one sound. Okay, loudness of first sound 110 minus, what is the loudness or of second sound? 50, right? Correct? 50. 110 minus 50 divided by, this 10 is part of the equation, divided by 10. So 10 to the power 110 minus 50 is 60, right? 60 divided by 10, that is equal to 6. Correct? 10 to the power 6. So difference in intensity equal to 10 to the power 6. Is it clear now? Okay, you were asking one question, right? One student, you can ask now.
Yes, the question is that how many times I think they want divide 110 divide by 50.
No, see how many times, what is that sound coming? Okay, how many times greater is the sound pressure level? Yeah, I think this is about, this question is about the intensity. Okay, this question is about the intensity, and when I refer the textbook answers, that is about the intensity. Okay, so how many times greater? It is 10 to the power 6 times greater. Okay, 10 to the power 6 times greater.
Said greater than 1.
Greater than, so here you have two sound, right? One sound is the rock music, right? Sound of rock music. Another sound is the like the sound is, means the loudness that we talk, right? The normal talk. So which one will have greater energy? The sound of rock music or the sound we talk? Rock music will have greater sound energy, right? Okay, so how many times greater? 10 to, that is the question. Okay, how many times greater is the intensity of this rock music sound compared to the normal talk? So when we use this equation and do the calculation, we get the energy or the intensity of rock music is 10 to the power 6 times, means 1 million times greater compared to the normal sound that we produce while speaking. Okay, yes. So there is one more thing in your textbook. This equation is not actually given, but they have written in words. So if I change that into equation, that will be like this. Okay, but I think that is not correct, because when I check the Google, ChatGPT, I spend much time to check that. So in that, when I study that, this is the correct way, and what I will write what is given in the textbook. Okay, difference in, if suppose there is a question like this, then if you write both, you should get the answer. Okay, you will get the answer. So in the textbook it is given 10 to the power, everything is same, but there is small difference, L1 minus L2 divided by, here I wrote 10, right? So in the textbook it is 20. Okay, so you will get to 10 to the power 3. Okay, is it clear?
Yes, but
Why there is a difference? That I don't know. Yes, tell.
What's correct?
This is the correct one. Okay, this is the correct one. This is the correct one. Okay. As this is given, for example, in multiple choice questions, so you have got a multiple choice question, then 10 to the power 6 is not there, but 10 to the power 3 is there, then you have to select 10 to the power 3. Okay, if 10 to the power 6 and 3 both are there, then you should get, or you must get answer for both, means you correct for both, you marks for both. Okay. Yeah, if there is two answer in the choices, you will select one, right? Okay, if you select any of the two, you must get the mark. So we will start with question number 7. Okay, define pitch and relate it to the frequency of a sound wave. So question number 7 from the EOT. So I will write EOT Q7. EOT question number 7. Define sound pitch and relate it to the frequency of sound wave. So what is pitch that I have given in the question? Pitch is, in the worksheet, pitch is the frequency of sound, right? Pitch is the perceived frequency of sound. For example, now I am talking. When I talk, that sound will have frequency. You are like different students, you are receiving my sound, right? So when you receive the sound, that is called the perceived frequency. The frequency you are sensing, the frequency of the sound, the frequency of my sound that you are hearing, that is the pitch. Okay, that is the pitch. Pitches are not related to the person who is producing the sound. Pitch is related to the person who is hearing the sound. Do you understand? Pitch is not related to the source of the sound. Pitch is related to the detector of the sound, who is detecting the sound, who is hearing the sound. Now the sound I am producing, you are hearing that sound. So what is pitch? Pitch is the perceived frequency of the sound. If that perceived that word perceived, if it make difficult for you, so if you write what is pitch, pitch is frequency. Remember this, just remember this. Pitch is frequency. Okay, pitch is frequency. Pitch is actually frequency of the person who is hearing the sound. At what frequency he is hearing, that is the actual meaning of pitch. So perceived frequency. Okay, perceived frequency. If I write perceived, then it is perfect. Perceived frequency of sound, that is called pitch. If you do not, if it is difficult to remember perceived, the word perceived, remove it. Pitch is equal to frequency of sound. A bird produces high pitched sound, whereas roaring of a lion is a low pitched sound. The voice of a woman has higher pitch compared to the voice of a man. So if I draw two sound, can you identify which one has more pitch and which one has less pitch? So this is one wave, one sound wave, number 1. This is another sound wave. Which one has greater pitch? Which one has lower pitch? Second one has the higher pitch, right? So higher pitch. How did you understand it has higher pitch? More waves, right? Because more waves. Because there are more waves. More waves means more frequency, right? More frequency means higher pitch. Okay, more pitch. Okay, very good. The next we have some question in that question number 6, 7, 8 and 13, right? Yes, question number 6 from the worksheet. what physical characteristic of a sound wave should be changed to alter the pitch and to alter the loudness? Pitch and loudness. So to alter means to change, right? Alter means to change. So to change the pitch, what the physical characteristic of sound wave should be changed? So what are the physical characteristics of sound wave? Frequency is one of the characteristics of sound. Frequency, amplitude, wavelength, speed. These are the physical characteristics of a sound wave. So to change the pitch of a sound, you have to alter frequency. Very good. Frequency. And yes, to alter the loudness of a sound, you need to change the amplitude of the sound. Always remember like this, okay? Like this is marked on a rock, like that, you remember. Pitch is always related to the frequency. Loudness always related to the amplitude. Like that, you make something, a card like this. Color the border. Okay. So you remember like this. Pitch is always related to the frequency of the sound, and loudness is related to the amplitude of the sound. Now I will move to the question number 7. When I erase this, you can read the question number 7. All of you read question number 7, okay, from the worksheet. Question number 7. The eardrum moves back and forth in response to the pressure variations of a sound wave. Sketch a graph of displacement of the eardrum versus time for 2 cycles of 1 kilohertz and 2 kilohertz. So we have to draw 2 waves. I hope all of you understand the question. We have to draw 2 waves. So when you draw waves, wave diagram, here we will give, because we need the time period, right? So this is time, x-axis we will mark time, here time, here displacement, so I will just write d for displacement. The eardrum moves back and forth in response to a pressure variation of sound wave. Sketch a graph of displacement of the eardrum versus time for 2 cycles. So we need to draw 2 cycles of waves. This wave has a frequency of 1 kilohertz, right? So I will write it. This wave has a frequency of 1 kilohertz, and this wave has a frequency of 2 kilohertz. So how to draw this? 1 kilo means 1000, right? Kilo means 1000. So this time I will write millisecond, okay? Time we will write in millisecond. So I will draw this wave like this. We need to draw 2 cycles. 2 cycles we need to draw. Very good. Not very good, right? Till once only. So I will increase this line length. Okay, now 2 waves. So here we will mark time in millisecond. This also I will make it little longer. Time in millisecond. Okay, so this is 1 wave, right? Correct? 1 wave. 1 wave. It has a frequency of 1 kilohertz. So what will be the time period? Time period will be 1 millisecond, correct? 1 millisecond, here I will write 1, here I will write 2 millisecond. So if this is 1, this will be, that point will be 0.5 and this point will be 1.5. Do you understand or any doubt? You understand or don't understand? Clear, right? Because 1 kilohertz, right? Frequency is 1 kilohertz. So what is the time period? Time period is equal to 1 by frequency. So frequency is 1 kilohertz. 1 kilo means how much? Kilo means 1000, right? Kilo means 1000. So 1 divided by 1000, that is equal to 0.001. Okay, the time period unit is second. So that is equal to 10 to the power negative 3 second. This is called 1 millisecond, right? 10 to the power negative 3. 10 to the power negative 3 is milli, right? So time period is 1 millisecond, the time taken to complete one wave. Okay. Which one? Here this question is just drawing. Okay, so if you are calculating, suppose you are calculating the time period, then you have to convert 1 kilo. How will you convert? Instead of k you need to write 1000, right? Kilo is equal to 1000. Okay, then this wave we have to draw 2 cycles, 1 2. Okay, 2 cycles, right? 2 cycles. So here it has a time period of 2 hertz, 2 kilohertz, right? 2 kilohertz, which means in 1 second it will produce 2000 waves. Okay, so here time period will be, here I will write 0.5, here I will write 1. Okay, so this will be 0.25, right? And this will be 0.75. Okay, 2 kilohertz, right? So so what should be the time period? Time period is equal to 1 divided by frequency, right? So 1 divided by 2000, right? So 1 divided by 2000, that is equal to, so when you calculate you will get like this, how much? 0.0005, right? So that is equal to 0.5 millisecond. Okay, 0.5 millisecond. Okay, done. So this is how you have to draw a wave which has a frequency of 1 kilohertz and another wave that has a frequency of 2 kilohertz. So I will erase this. Yes. Okay. 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 In this question, you have to draw 2 waves. Okay, you have to draw 2 waves. So we are drawing 2 waves. This is the first wave. This is the second wave. And in the question they stated one wave, it has a frequency of 1 kilohertz. Okay, for the one wave it has a frequency of 1 kilohertz. So how to draw a wave with a frequency of 1 kilohertz? And they said in that diagram there should be 2 cycles. So we draw a wave like this. Okay, 2 cycles, done. Then we have to decide what should we write on the time axis. So it should have frequency 1 kilohertz, right? Which means this wave complete 1000 waves. Okay, it complete 1000 waves in 1 second. Do you understand? 1 kilohertz means that wave complete 1000 waves in 1 second. So how much time will it take to complete one wave? One wave. How much time will it take to complete one wave? It will complete one wave in a time of 1 divided by 1000 second, right? 1 by 1000 second. 1 by 1000 second is called 1 millisecond. Okay, 1 millisecond. So the time taken to complete one wave, okay, time taken to complete one wave, that is equal to 1 millisecond. Okay, so I wrote here 1. Okay, so millisecond we are writing here. Okay, on the axis we mentioned already like this, time we are labeling in millisecond. Okay, then wait, then we have to draw the second wave. The second wave has a frequency of 2 kilohertz, which means this wave will complete 2000 waves in 1 second. If it complete 2000 waves in 1 second, what will be the time taken to complete one wave? To complete one wave, it will take a time of, to complete one wave, it will take a time of 1 divided by 2000, right? 1 divided by 2000 is equal to 0.5 millisecond. So the time period of the second wave is 0.5 millisecond. Time period means time taken to complete one wave. So we wrote here the time period means time taken to complete one wave is 0.5 second. So 5 millisecond. Okay, 0.5 millisecond. So time taken to complete two waves, 1 millisecond. I can erase, right? Done? Can I erase it?
Yes, sir.
Oh.
How did I understood the equation, but how did we decide here 0.5 here it is 0.5?
Okay, that is the explanation I gave, right? That is the same question asked. So 2 kilohertz is here, okay, 2 kilohertz. Then what is the meaning of 1 kilohertz? 1 kilohertz means this wave is completing 1000 cycles. This is called one cycle, right? One crest, one trough. That is called one wave or one cycle. So this wave is completing 1000 waves in 1 second. That is given in the question, right? So if it to complete 1000 waves in 1 second, what will be the time taken to complete one wave? Time taken to complete one wave is 1 divided by 1000 second, right? 1 divided by 1000 is called 1 millisecond, right? 1 millisecond. So the time I have to mark here, right? Here this axis I have to mark time. So this is one wave, right? One crest and one trough. This is called one cycle. So it takes 1 millisecond to complete one cycle, 2 millisecond to complete two cycles. Do you understand?
Yes.
Enough? Okay. Now we will go to the next question. Question number 8, effect of medium. All of you read the question. List two characteristics of sound that are affected by the medium and through which the sound passes, through which the sound passes, and two characteristics that are not affected by the medium. So what are the two characteristics of sound that are affected by the medium that we have discussed in some of the question we discussed previously? So affected by medium. Can you tell any of the characteristics of sound, right? Yeah, any of the characteristics of sound that is affected by medium. Can you tell? Yeah, first one is velocity, and we can call it speed also, right? Velocity or speed. Yes. Second one is wavelength. Very good. Wavelength. Whenever speed change, wavelength will also change. Very good. Then tell two characteristics of sound that are not affected by medium. Not affected by medium. Yes, first one is frequency, right? Okay, frequency. And second one we will write a time period. Okay, time period depends only on frequency. Time period or period. Question number 13 is about standing waves. So this question we will discuss in detail when we are discussing standing waves, okay, there will be questions about standing waves in the Haikal. So when we reach there, we will discuss in detail. Now I will discuss in short, still you will understand. So there are two resonance, right? Okay, so you can learn from here. First, number one, this is one wave, right? Correct, one wave. So this is equal to one wavelength. One wavelength means length of one crest, this length, and length of one trough. This is crest, this is trough. Length of one crest plus length of one trough, that is equal to one wavelength. So what will be this length from here to here? From here to there, that will be equal to lambda divided by 2, means half of the wavelength. Distance from here to here is half of the wavelength. What will be the distance from here to here? This will be equal to quarter, right? Lambda divided by 4. Just remember that one full wave, length of one full wave is lambda. So length of half of the wave is lambda by 2. Length of quarter of the wave is lambda by 4. Number 1. Then next we will draw two waves. So we will draw waves in, I will discuss the standing waves in detail later. We will just draw two waves. So this is first resonance, okay, first resonance, so we call fundamental, one harmonic, and this is the second harmonic. Wait, second harmonic. Okay, so you can see here this one is called one node. This open like this, mouth like this, open like mouth of a shark, that is antinode. So node, antinode here, antinode here, node here. Okay, or I will, no problem, just for you to understand. Okay, then next you can see here, if this is one full wave like this, so this part up to here, this is a quarter, right? So this you can see, this is a quarter of a wave, this is a quarter of a wave, and this is half of the wave. So this wave has one quarter, right? This wave has one quarter, length of one quarter is lambda by 4, and this wave has half of the wave lambda by 2 and one quarter lambda by 4. So these are the two resonance, the spacing, okay, I will write the word spacing between two adjacent resonance, it is called harmonics. Okay, two adjacent, so two nearby, I will just write two harmonics, it's actually two nearby harmonics. Spacing between two harmonics is always equal to, you can see here there is lambda by 4, right? This is a lambda by 4, a quarter of a wave. Here we have 1 quarter and 1 half. Here we have only 1 quarter. Here we have 1 quarter and 1 half. So the difference is always lambda by 2. Difference is lambda by 2. So in this question, do you understand this part, this section? Do you understand this? What did I say here? Okay, what I said is this is all about standing waves. Okay, this question is from standing waves. So I will just draw standing wave like this. So when we draw the standing wave like this is like a half of a wave. Okay, this is half of a wave. Why? Because a wave means it will have a crest and a trough like this, right? So this is a wave. Okay, so when we draw standing wave, if we take this one full, this is one wave. Okay, so if I draw only like one loop, that is actually equal to lambda by 2. Okay, this is when you see the standing waves image, you will see like this, right? So this is half of a wave. Okay, that represent half of a wave. Half of a wave means its length is lambda by 2. Okay, so if this is half of a wave, these are the two quarter, right? This is one quarter, this is another quarter. Okay, can you remember that? This one. Okay, this middle line is not there. Okay, this is one quarter, this is another quarter. If you join, this is one full half, right? So one quarter. Okay, so first wave you can see, this one you can see there is only one quarter, right? Correct? Okay, here you can see in the second one, you can see there is one quarter, this is one quarter, and this is one half, right? Okay, so the difference between two nearby harmonics will be always by a half of a wave. Okay, half of a wave means lambda by 2, right? See, one quarter, I will write here one quarter. So here there is one quarter here, right? One quarter plus one half. So what is the difference between that? The difference is one half, right? Because one quarter here also there, here is also one quarter, here one half is also there, so the difference is one half. Spacing between, or the difference in length between two harmonics will be always lambda by 2. Okay, so in the question they have given like this: a 440 Hz tuning fork is used with a resonating column to determine the velocity of sound in helium gas if the spacing between the resonance is 110 centimeter. The spacing between resonance, right, that is given in the question. Okay, spacing is equal to, spacing means distance or length, whatever you call, same thing. As it is given spacing in the question, I am writing spacing 110 centimeter. We need to do we have to convert this into meter or not? Everything we have to write in, yeah, okay. So how to convert into meter? Divide by 100, right? If I divide by 100, it will be 1.10. Okay, spacing is equal to 1.10. So we can write 1.10 spacing, that is equal to, or lambda by 2, that is equal to 1.10, right? 1.10 meter, because spacing is always equal to lambda by 2, and in this question the spacing between two harmonics will be, is the spacing between two harmonics is 1.1 meter. So we can write like this. From here we will get the value of lambda. So lambda is equal to 2 times 1.10, that is equal to 2.20 meter. That is the wavelength of this wave. Now we know the frequency is given in the question, right? Frequency of this wave is given in the question. 440 Hertz is the frequency of the tuning fork. Question is, if the spacing is 110 centimeter, what is the velocity of the sound? The equation to calculate velocity of the sound is frequency multiplied wavelength. frequency is directly given in the question 440. Wavelength was not directly given, that is why we used this concept to calculate the wavelength, and after using that concept we calculated the wavelength and we got 2.2, right? 440 multiplied 2.2, that is equal to 968 meter per second. Yes, if they are not giving the wavelength, they will definitely give the spacing. Okay. Like in this question. Now you can go to, now we have done with the question number 7. Okay, now you can go to question number 8. All of you read question number 8. Okay, please read question number 8. Doppler effect means like for example, if there is a something music or something is going on, so you are walking towards that, you want to watch that, you want to listen the music, so you are walking or you are driving to that place. Then when you are traveling towards that, you will be hearing an increase in the frequency of the sound. There will be an increase in the frequency you are hearing. Or for example, you are standing beside the road and a police van or an ambulance is coming with its siren on. So when it is coming towards you, you will hear an increasing sound, right? Increasing frequency, that is called Doppler effect. Do you understand what is Doppler effect? Okay, for example, I am standing here and a police van or an ambulance is coming. I am standing beside the road, or I parked beside the road. The ambulance is coming. So when it comes towards us, we will hear an increasing sound, right? An increasing frequency. That is called Doppler effect. So I have given in the worksheet, Doppler effect is the change in the detected frequency, because the frequency of the source is not changing, right? The source is producing the same frequency. Okay, when it is moving, it is not changing the frequency of the sound it is producing. Only the frequency is changing for the listener. So that is why I gave like this. Doppler effect is the change in the detected frequency due to motion of the source or the motion of the detector, or both. So that is the definition for the Doppler effect. The change in the frequency due to the motion of the source. Source means the object that is producing the sound. Detector means the person who is hearing the sound. Okay, so there are 3 questions given. 1, 2, 3. Okay, 3 questions, right? Only 3 questions given. First one, example problem 1. It is from page number 34 of your textbook. Wait, I think I missed one sheet. Just 1 minute. Yes. Question number 8 in the worksheet. Okay, worksheet page number 7. Okay, in the worksheet page number 7. Page number 8 also there, right? I think I have sent it, right? I forgot in the printer. Okay, so yes, page number 7. Okay, page number 7, question number, in that you can see example problem 1. A guitar player sounds he produces a sound with a frequency of 523 and he is in a car. This is a car. The guitar player is inside the car, so he is the guitar player, that man. Okay. You are here. So this guitar player is making a sound. It has a frequency of 523 hertz, and he is moving towards you. The car is moving towards you. The car is traveling with a speed of 24.6 meter per second. You are not moving. You parked here or you are standing here. So you are at rest, not moving. Okay, so what is the frequency you hear? So we need to calculate the frequency you hear, that is called frequency, detected frequency. That is what we need to calculate. So in Doppler effect we have this equation. The detected frequency is equal to frequency of the source multiplied V minus Vd divided by V minus Vs. Okay. Do you understand each term in this equation? What is FD? Detected frequency, right? Detected frequency. Then FD, okay? Fs. What is Fs?
Frequency of the source.
Yeah, source frequency. Okay, frequency of the source, correct. What is V? V is speed of sound. Okay, speed of the wave, in this case it is sound, so speed of sound. Vd, speed of detector, and Vs, speed of source. Okay, speed of source. So I will write those things. Fs, Fd, V equals Vs equal Vd equal. Okay, so in this Fs, what is the source frequency? It is given in the question. The guitar is making a sound of 520, how much? 523, right? 523. So 523 hertz. We need to calculate the detected frequency. Speed of sound in the air will be 343 meter per second. Vs, speed of source, is 24.6 meter per second. And speed of the detector is 0 because detector is not moving. So here velocity has a direction, right? In this case, if the source is moving towards the detector, S to D, okay, S to D, positive, okay, plus, I will write a plus. S to D is plus. Detector is moving towards the source, minus. Okay, this is the sign convention here. Source to detector is positive, detector to source is negative. Okay, now I will apply these things in this equation. Can I erase this part? Okay, right?
Yes.
Okay, so we will apply these things in this equation. So detected frequency is equal to frequency of the source 523 multiplied 343, right? 343 minus 0 divided by 343 minus 24.6. Do you understand? I did it a little faster. So the answer will be which one? How to know which equation to use, right? Okay. So here, if the car is moving towards you, right? The question, when you read the question, you will understand it is from Doppler effect, right? Okay, in Doppler effect you have only one equation. Okay, if you understand the question is Doppler effect, this is the only law. Okay, yes. 343, right? The speed of sound in air, the speed of sound in air, that is 343 meter per second. Okay, at a temperature of 20 degrees Celsius, means at a room temperature 20 degree Celsius. So here in the question it is given, if the car is moving towards you, what frequency would you hear? Assume the temperature is 20 degrees Celsius, means the person is inside the car and you are outside the car. So in which medium the sound is traveling? Sound is traveling through air, right? Sound is traveling through air, and you can hear that sound. So speed of sound in air is 343. Okay, done. Can I erase? Okay. You can see next question, question number 1. Repeat example problem 1, but the car is moving away. So if the car is moving away, here you can say in this question, this is the source, right? This man is the source. This is the detector, right? So here you can say it is moving from source to the detector. That is why this is positive. Okay. In the next question, you can see this car is moving away, right? If it is moving away, this will be minus. Okay, this will be minus. Do you understand? If that is minus, here there will be minus. You are in an automobile, so here is a tower or a post, and on this post there is a siren. So this is the siren which is making sound. So it is making sound with a frequency of 365 hertz. And you are in this car. Car like this, two tire. Okay, you are in this car, you are moving towards this. So you are moving with a speed of 25.0 meter per second, 25 meter per second. Okay, yes, so this is not moving, only you are moving. Yes, so I will write these things in Doppler effect. We have Fs Fd equal. Okay, here I will write V equal, Vd equal, Vs equal. Okay, Fs, frequency of the source, how much? 365 hertz. Frequency of the detector, we need to calculate at what frequency you inside the car hearing that sound. V, speed of sound in the air, 343 meter per second. Vd, speed of the detector, 25.0 meter per second. So here you can see what is the direction of this velocity. This is detector, right? Detector. This is source, right? This is source. You can see detector is moving towards the source, right? So the direction is D to S, right? Direction of velocity is detector to source. I said like this: source to detector, S to D. S to D is positive, D to S is negative. Okay, so this velocity will be negative. Okay, Vs, source is not moving, right? Siren not moving, siren is fixed on a post. So we will write the Doppler effect equation here. A Doppler effect equation for Fd, that is equal to Fs into V minus Vd divided by V minus Vs equal. So how do I remember this? I remember in alphabetic order, like Vd come first, right? In like S come second. That is why. So here you can see Fs is 365 multiplied V minus V is 343. Minus, right? Minus 25 divided by 343 minus Vs is 0. So this minus will be plus. So if you use a calculator, you can use a calculator to find the answer. You will get 392 hertz. 392 hertz. So you can see here the actual frequency is 365 hertz. As you are moving towards the source, the received frequency or the detected frequency is increasing because of the motion, right? That is the Doppler effect.